voltmeter. See, voltmeter is a device which is used to measure the voltage between any 2 points in a circuit. Suppose this is the circuit. We say here, we have a circuit like this. So between this point A and B, we want to find what is the voltage between this portion, between these 2 points. So it is a voltage measuring instrument in circuit, and it is connected in parallel in the circuit. First let us see how a galvanometer can be converted into a meter. See, this is the galvanometer. This is a galvanometer with galvanometer resistance G. This is our galvanometer, where G is equal to galvanometer resistance. Why galvanometer has got a resistance? Because the current is flowing through. In galvanometer there are coils through which the current is flowing, so the coil will have a resistance. So Ig, let us call Ig. So this is the current Ig. Ig is equal to full scale deflection current. See, if I is less than Ig, this galvanometer will show deflection, but it will have less deflection. So galvanometer needs such a current which can give full scale deflection. That is, suppose this is the full scale deflection, this is zero scale deflection. If I flowing is less than this one, it will show up to here only the deflection. If I is equal to Ig, then it will show full scale deflection. That is the difference. So we call it as a full scale. Ig is the galvanometer current passing through the galvanometer for full scale. And coil resistance is, it has got a resistance G. And this galvanometer can be converted into voltmeter by connecting a very high resistance in series, and that is connected in parallel with in the circuit. So series parallel, the confusion always comes. Always we remember this one, VHS, something we must have seen in the camera also, digital camera as well as TV. And we see one more thing, PAL. This we don't record, we will take this one. V stands for voltmeter. H stands for high resistance. And S stands for N series. It means what? We are going to connect this is the galvanometer which has got a galvanometer resistance G. So we are going to connect in series. It means with this we are connecting a high resistance. We call it as R in series. High resistance in series, then this arrangement become voltmeter. This is our motor, and this arrangement is connected in parallel between the points in which we want to find out the potential difference. We connect this galvanometer like this. That is in parallel in this circuit. That's all. You need not to worry about it. In ammeter, we don't need this ammeter. See, ammeter means ammeter, high resistance, low resistance, it will be connected in parallel. It means series and parallel. For galvanometer, series and parallel. And ammeter is connected in series, and voltmeter is connected in parallel. That's all the difference. This assembly, we connect it across this point. And this assembly is known as voltmeter, and is connected in parallel between the points where the potential difference, that is between this point A and B, where the potential difference has to be measured. That is the voltage across A and B, or potential difference across AB in this circuit. So this is the way how we make the Now, what is the value of the R? Because this is the R series high resistance connected in series, with the galvanometer. So, what is the potential difference across this? V is equal to, what is V is equal to I into R equivalent. Why we call it equivalent? There are two resistance, 1 and 1. That is V is equal to I into V is equal to I means what? I means galvanometer. I means this is Ig, the current flowing through the galvanometer. So Ig into R equivalent is galvanometer resistance plus the resistance, high resistance, which we are connected in series. That's all we got this R. R V is equal to Ig into G plus Ig into R. So since we need R we can simply write Ig into R. Ig into R is equal to V minus Ig into G R. R is equal to V minus Ig into G divided by R divided by Ig, divided by Ig. R is equal to the value of the resistance given by this value V minus Ig minus G. This is the value of resistance. So here it is connected in series to convert it into voltmeter, and this assembly is connected in parallel across the circuit, in which we have to measure the voltage across this point. So this is all about voltmeter. Regarding voltmeter, the reading of voltmeter is always less than the true value. Why? See, now this is the resistance. I is the current flowing, and this is the resistance. The voltage across the potential difference across the resistance is equal to I into R. This is true value of potential difference between this point and this point. But in actual case, we connect a voltmeter, and that between these 2 points we connect the voltmeter, and that voltmeter will also show the potential difference, but that value will always be less than the true value. Why? Let us see. See, this is voltmeter. We know how voltmeter means. We use this formula VHS. This is voltmeter, high resistance, this is in series, that is with a galvanometer. See, this is the galvanometer. With the galvanometer, we connect a high resistance in series, to convert a galvanometer into voltmeter. This is the voltmeter. By connecting a high resistance in series with the galvanometer is converted into voltmeter. Now we will put this one here, the same circuit. This is the circuit. This is a circuit in which I is flowing. Now we connect a voltmeter, this same arrangement, that is a galvanometer into high resistance. This is the voltmeter. This connection we connect it across this point. So this is, we can say, this is a voltmeter, which will give a reading. What it will give? It is supposed to give the same reading, because we have what is the voltage across this one is equal to I into R, and this also supposed to give I into R, but this value of V dash will be less than V dash, less than the true value, less than V. This is V dash is equal to measured value, measured between this potential difference between these 2 points, measured value of potential difference across this point. If we are connecting a voltmeter, this will be very low. Let us see how it is. Let us see the galvanometer will have a G is equal to galvanometer resistance, galvanometer resistance G. R is the, as it is the origin, is equal to resistance given. Resistance is given. What else we have? We have a resistance RS. What is RS? RS. See, along with the galvanometer resistor, there is a resistor in series with the voltmeter. This is RS. This assembly we have put it here, and this has become a voltmeter. RS is equal to series resistance in with in galvanometer circuit. See, RV. What else we have? See now, what is the? This is the RV. RV is equal to voltmeter resistance. That is voltmeter resistance, where RV, that is voltmeter resistance, is equal to galvanometer resistance plus the resistance in series. Both are in series. Or we can write RV is equal to voltmeter resistance, which is equal to galvanometer resistance, and resistance connected in series with the voltmeter. These are the resistance. Now, what is the total resistance now? What is the potential? See the potential, suppose point A and point B. Say this is point A and point B. We connect to measure the potential difference across this resistance. We connect this voltmeter across it. It is in parallel with it. We connect the voltmeter always in parallel in the circuit. So what is its? So whatever is the value of the potential drop should be the value of the potential drop across it, because both are in parallel. Let us see what is V dash. But now let us see V dash. Let us call it as this potential drop as V dash. What is V dash? Is equal to I into R equivalent. Why we call it is equivalent? Because there are two resistance. There are 1, 2, 3 resistance. These two are in parallel with this one. So RV, what is RV? R equivalent. What is this R equivalent? R equivalent is equal to this total thing, we call it as RV. RV is equal to G plus RS is equal to RV. R in the circuit, R into this total entire thing become resistance of galvanometer, resistance of the voltmeter, RV. So these and these are in parallel. So R equivalent is equal to R into RV divided by R plus RV, because this and these are parallel. This and this in parallel. So we can write V dash is equal to I. What is I? I into R equivalent is R into RV divided by R plus RV. And this we can write I into R into RV divided by R plus RV. So therefore V dash is equal to I into R. What is I into R? Here I into R is equal to V, the true value. So this will become I into R is equal to true value into resistance of total resistance of voltmeter into R plus RV, which is equal to V into 1 divided by, let us take it down, R plus RV divide by RV. Therefore V dash is equal to V into this and this, 1 divided by R by RV plus 1. Now you see what is the difference. See, we can conclude V is equal to I into R and V dash is equal to, what is V dash? V dash is equal to V into RV divided by R plus RV. It means V dash, since RV divided by RV divided by R plus RV will be always less than 1. Why? Because this is bigger one, this is smaller one, it will be lesser one. It means this is less than 1. It means we can say V dash is equal to V and some value which is less than multiplied by less than 1, that is point not something, that is V dash is less than V. So where V dash, what is V dash? V dash is the where V dash is equal to value of voltmeter. Value of this one as read by this voltmeter, that we call it as a V dash. V dash is equal, this is the value less than. So as it is, we have proved, what we have proved in this, we have proved that V is less than V dash is less than V. This is the true value, this is the value shown by the voltmeter. Now we can write from here also, where V dash is equal to V into 1 by R by RV plus 1. Suppose if V dash to be equal to V, then what? Then RV should be infinite. Why it should be infinite? R divided by infinite, this will become anything divided by infinite is equal to 0. When 0 plus 1 is equal to 1, 1 divided by 1 is equal to 1. In that case, V dash, what will be V dash? So V dash is equal to 1 by R divided by infinity, since RV is infinity, plus 1 is equal to 1 by 0. Anything divided by infinity is 0 plus 1. Sorry, this is V into 1. So this is equal to V into 1 is equal to V. It means we can come to the conclusion that for V dash to be equal to V, then the condition is voltmeter resistance should be equal to infinity. In that case only this condition will be met. It means what? The reading of the voltmeter is always less than true. Understood? If the voltmeter is connected across this R, it will give you a value of V dash, when what is the original value of potential difference across this is equal to I into R. So it means if RV, the voltmeter resistance, RV is equal to voltmeter resistance, that is G plus RS. G plus RS should be infinity. It means we can conclude, what we can conclude? For an ideal voltmeter, the resistance of voltmeter should be infinite. If the resistance of the voltmeter is infinite, in that case only this is equal to this one. It means for an ideal voltmeter, its resistance, that is its resistance, voltmeter resistance should be infinite. It means, of course, there is no ideal voltmeter is not possible. There will be some resistance across this voltmeter. So ideal is not possible, but this question have come several times in the board as well as in the NEET also, that what is for an ideal voltmeter, what dash should be infinite. That is, the voltmeter resistance should be infinite. That is, the ideal voltmeter, the resistance of the voltmeter is infinite.